Hey everyone, in this video we're going to be looking at how to graph a quadratic equation. Now, there is some previous knowledge that you will need. Given any of these three forms of equation, you should by now be able to find the vertex, find other key features, specifically the vertex, and A, the coefficient, is what we're looking for here. If you don't know how to do that, go learn how to do that, come back, I'll show you how to graph. So here we go. If we are graphing a quadratic equation, there are three steps. The first step, find the vertex of the function. This is why I said it's very important that you know how to do that. If you don't remember, here is a flashing at you of that chart. Pray that it's in vertex form. If not, you still know how to find it. So find the vertex. Then we need to find A from the function. And if you'll remember, that is just the coefficient. So if we're looking at our three forms, A is there in vertex form, there in factored form, there in standard form. We just need to read it out of the equation. So nothing too complicated there. Find the vertex, find A, and now comes the part where it won't make sense and you need more explanation. Then we're going to use A times x squared, what do I mean by x squared? To find other points. So let me explain what I mean by x squared, because it'll be a little different than maybe what we're used to. So let's take our equation y equals 2 times x plus 1 quantity squared minus 8. I have conveniently color-coded for you which form that is, even though you should know that it is vertex form. And so our vertex here is going to be -1, -8, and A is 2. So I have done that hard part for you. What we need to do now is look at how do I take this vertex and find my next point. Well, let's think about what we do know. We know that A is positive, so this thing is going to be concave up. So my parabola will go this way in some form or fashion, but I still need to know how to find that next point. So here's what I do. I'm going to go ahead and show you where that next point is and then explain how we got there. So here's what I did. Starting from the vertex, I just moved over on the x dimension, so left or right. I moved over one space, just one. And then if I need to know, starting from the vertex, if I go over one space, the amount that I go up is going to be A, 2 in this case, times how many ever spaces I moved from my vertex squared. So here A is 2. I moved over one place from the vertex, so I would do 1 squared. Well, 1 squared is 1, 2 times 1 is 2, so I would go over 1, and this is all again from the vertex, over 1 and up 2. Now the interesting thing about a quadratic is that it doesn't matter which direction we go from the vertex, it's the same thing. So if I want to go to the other side, if I go one space over, I go A, 2 in this case, times that many spaces squared. So 2 times 1 squared would be 2, so I go over 1 and up 2. And this pattern works no matter how far I go. So to find my next 2 points over, if I'm going 2 places to the right in this case of the vertex, I would go up by A, 2 times 2 squared. So 2 squared is 4. 2 times 2, or 2 times 4 would be 8. So from the vertex, I go over 2 and up 8. And I would do the same thing on the other side. So what happens is if I wanted to, say, go 3 spaces out, then I would go over 3 and up 2 times 3 squared. Well, 3 squared is 9. 2 times 9 would be 18. So I would go over 3 and up 18. And you can see why I didn't put that point on there. There's just not enough room. But at this point, I already have my vertex, and I've got 4 other points. That's more than I need. I need my vertex and 2 other points. And when I do that, I can graph the parabola just by connecting the dots. And there it is. I have graphed a parabola. So remember, 3 steps. Find the vertex of the function, find A from the equation, and use a times x squared, where x is our distance from the vertex, to find my other points.